Hey guys, long time. So I've worked on a project for a while and I'm finally done with the project. So how did I come about this project? So first of all, I came about the case study where the temperature of each room in a building has to be monitored. And the most basic way to do it was to install an ESP in every room and then let the ESP push the temperature of the room to the cloud. Basic stuff. But there were some constraints. One question was that the Wi-Fi in the building is not reliable. Two was that it was a 5 gigahertz network and all ESPs use 2.4 gigahertz network. The head of a C5, ESP32 C5 as dual band. That means can use both 2.4 and 5 gigahertz network, but I couldn't find it anywhere. So I just set it for the other ESP that use 2.4 gigahertz. Now, there's no way to connect ESP to the internet because there is no Wi-Fi network to use. But the other option was to use a cellular connectivity board. But now, for me to do that, I had to connect the cellular connectivity board to all my ESPs, and they can be quite pricey because this case study they could up to 30 rooms in the building. So buying 30 cellular devices would be an overkill and to be expensive. The other option was to buy a 2.4 gigahertz Wi-Fi network and install the building. But there's a problem in that range. When most of us have Wi-Fi in our home, there's a range it can reach, and the building is quite large. If some devices are far away from the router, they won't be able to connect to it at all because of the distance, because of the range. So the other option was to get extenders to put at different Wi-Fi extenders put at different points in the building. Mother also cost some money. So the most viable option I thought about was to create a mesh network where one of the devices acts as a router. So what is a mesh network? A mesh network is basically a connection of devices. It's like a chain of devices exactly. So each device is connected to the adjacent device, then the adjacent device, the adjacent device, then so on and so forth. With this kind of connection, data can hop in between devices until it gets to the destination. For example, I have 26 devices, letter A to Z, and that 10 meters apart. So A and B are 10 meters apart, B and C are 10 meters apart. That means A and D will be probably around 20 meters apart. Although they are far apart, if I want to send the message from A to D, if D is not the range of A, the message can hop through B, then to C, then to D. So it kind of gets rid of the problem of range. Same happens if I want to send the message to device Z. It hop from A, B, C, D all the way until it gets to Z. And it's not that slow from may sound while I'm saying it. It's actually quite fast. It can go from A to Z really fast. So that was the solution I came up with. Now one of the devices act as a router, meaning that only one device will have cellular connectivity. The board I used for cellular connectivity was the blue cellular Notecard. One thing I like about blues is that this problem I have with connectivity to the internet, which is while I'm trying to send that to the internet, if there's no internet connection, two things usually happen. Is either it blocks my whole code waiting for internet connectivity to arrive. If it doesn't arrive, the whole code is blocked, meaning I cannot receive any data from other devices. Nothing will happen. The whole code will stop running until internet connectivity comes back. Then the data is sent, or it just drops the data and moves on. But with Blue's cellular Notecard, what it does is that, or not the cellular Notecard, Blue's has other Notecards I'll get into later. So the Blue's Notecard, when there's no internet connection, all the messages queues on the Notecard. You can queue up to 100 messages. So when the internet connection, it then pushes the data to the internet, and this does not block my code from running because like the cellular Notecard is separate chip from the main MCU, so this doesn't block my code from running. And this is one thing I like about the cellular Notecard or other Bluetooth Notecard. One of the things I like about Bluetooth Notecard is that you can easily swap out the connectivity options. They have the cellular Notecard, the Wi-Fi Notecard, and the LoRa Notecard and satellite Notecard. I can just swap out devices to use, and I don't have to change a single line of my code. The Notecard work with the note carrier. The note carrier is basically something that carries the Notecard, as the name implies. So you just plug into your note carrier, allows you to use the Notecard. So there are various note carriers. There's node carrier A, there's node carrier B, there are other node carriers you can see here on the side of the screen. For this project, I use node carrier A because it has an external SIM slot. Why am I using external SIM? Because of the Blue's embedded SIM card does not work here in Nigeria. So the each Blue cellular device comes with 500 MB and 10 years of cellular service. But unfortunately, I can't use that here in Nigeria, so I have to use my MTN SIM card. So now let's talk about the way we measure temperature. For measuring temperature, I use the DS18B20 temperature sensor. Basically, just is a one-wire device that measures temperature and send data to our ESP32. It takes that data, pushes to the router device pushes it to the cloud. Boom. Very basic. So the next I want to show you is the device. So I have two devices. We have the non-router device and the router device. Now, the router device is the device in the mesh network that has a router. This is a typical example of the non-router device. So it doesn't have a router, just an ESP with a temperature sensor and an AC supply. For the router device, the enclosure I ordered for it is not yet ready, but you can see it here. So I have the blues and the ESP. I don't use a carton to hold them together until my enclosure arrives. So you can see I'm using the MTN SIM card there. Works pretty well with GPRS. So with the blues you can use different modes of cellular connectivity. There's the NB IoT, there's GPRS, there's 4G, there's LTE-M, but only GPRS seems to work here in Nigeria. I don't know, 4G works on my phone. I don't know why they didn't work here. So the schematic for the non-router device is over here on the screen, where you can see the schematic for the router device here. So basically the difference between the router and non-router device is just the Blue's note card. So now let's go to how the device works. Let's see the device in action. This is the router there on the table. There we have the temperature sensor, the DS18B50, and we have the note card and note carrier over there on the right. This is the USB to serial converter as an AC power supply, but using USB, so you can see the output on the computer. Now let me show you the other nodes. So the next node is just by the door. So when I open the door, you should see the node. So yes, that is what is one non-router device putting its temperature to the router device there on my table. See that you can see the temperature sensor over there. So now let's go to the location of the other node. So it is quite in a dark area, but I'm just going to show you. So just turn right here. As I said, it's quite dark. And that's the other node. So this is another non-router device. So you can see there it is on temperature sensor, also putting its readings to the router device. So here's the serial terminal of the router device. I'm going to use to explain how the whole communication process works. As you can see, there are messages coming in and leaving the router. This is a clip from my serial terminal. I'm going to use to explain how the whole communication process works. So the first thing that happens is that the router device broadcasts ID to all the devices in the network. And when all the devices receive this ID, they used to know who to send that temperature to. They used to know who the router is. So each device in the network has a unique ID that can be used to identify them. I said earlier, the router broadcasts this ID to the whole network. So broadcasts it so everyone in the network can see it, or every device in the network can see it. And when they receive this ID, they can know, oh, I found the router ID. They now broadcast they don't broadcast them. They send their temperature reading straight to the router. The difference between broadcast and sending. When you say that now, the broadcast means I'm sending to everyone in the network. If I'm just sending, I'm sending straight to one particular device. The router is the only one that broadcasts. While the other device is, I'm going to call it sensing. They sensing to just one device, and that means they send straight to the router. They don't broadcast. Now, if one device is far away from the router, as I said earlier, data can hop from one device to the other until it gets to the router. As you can see, the third communication line here. See what happened. But before I go there, let me show you the two communication lines above. These two parts is basically the router broadcasting its ID. Now, this third communication line over here, the router received a message from this device. I'm going to use the last 3 digits, which is 837. But how did it get to the router? I think it received the reading from 837, but it came from 637 before getting to the router. That means the data hopped from 837 to 637, then to the router. If you come to the last line, 637 sent its own temperature reading straight to the router. As you can see, there's no route package here. It went straight to the router, meaning that 637 directly connected to the router, while 837 is connected to 637. So that way, the message from 837 hopped to 637, then to the router, while 637 goes straight to the router. So now here's the Blynk console UI. Also want to look at the notable UI. Before we get into that, if you want to build this project, I'm going to leave a link in the description below where you can find the materials needed for this project, a guide to build this project. You're going to find the code, basically everything you need to set up this project. So the link in the description below. So now let's go into the UI. Now for the UI, as you can see, so what I have to do is to press the switch and wait for the temperature readings to update. So we can go to Note Hub and go to events. You see that blynk.q inbound note has been sent. But we just need to wait for the Notecard to respond back with the temperature. So as you can see in our events, it has successfully been routed to Blynk. And see the temperatures 26, 26, 26 for different rooms. So all the rooms have a temperature of 26 degrees Celsius. So if you go to Blynk, you see the same thing, 26, 26, 26. Now we're going to do the same thing on the mobile app end. So open your Blynk mobile app, you see your device that we created there already. Then we click on it. Then we can see the last value you sent, 26, 26, 26. The same thing here, 26, room 226, and the router 26. So when I click the refresh button, it'll take a while, but it should update the temperatures. Now the temperatures could be the exact same thing. So for us to be sure that actually being updated, we'll use Note Hub to confirm that. So let's reload the events. So you can say Blynk 10. So it updates anytime blynk.q arrives. It does not check the message as blynk.q is sent, just checks if blynk.q has arrived. So I think it has arrived from the way my Notecard is blinking. Okay, yes, so it has arrived. So you should see the update. Yes, as you can see, the 27. So roughly took 5 seconds. Really, did it take 5 seconds? Okay, no, it took up to a minute. So from 33 to almost a minute to arrive, but that's fairly okay. Thank you guys for watching this video. Remember, I said earlier, if you want to be able to build this project, just check the link in the description below. I have linked the hacks.ai article that has all the materials needed to build this project from scratch to finish. So bye.